The question is, you see the formula here, sine, these are called double angle formulas because there's a 2 here, okay? So then there's a half angle formula, then this is divide by 2. So if it is double angle formula, y sine 2 theta, so we want to know why is this, why it looks like that. So in place of 2 theta, we need to prove that, right? So I want you to replace this, everything stays the same. Instead of 2 theta, what should I write? That's my question. Okay, so sine remains sine, okay, let's write that quickly. Sine remains sine, but in place of 2 theta, I want to replace it by, if you see the chart, that formula yesterday's, sine of what? Plus, what should I write here in this? Come on, huh? 10 and 10?
Oh, it was 2, that's not 20.
No, it's 2.
It's theta.
It's 2. Oh, I thought that was 20.
It's a theta. It's a theta. Theta.
Oh. No wonder I was like, I thought it was 22.
It's the variable. It's a Greek letter. Okay?
Yeah.
Yeah. So how do I write that? Instead of, so how many thetas are here? 2 of them. So how do I separate them?
T theta, T2 plus theta.
Yeah. So that's all I'm asking. So that's right. So you can write this as theta plus what? Plus the, so the red one and the, is that okay? And do you remember that formula for sine? What is the formula for sine? Sine of a plus b. How the formula worked from yesterday? Sine a plus b. Check your notebook quickly.
Sine A times.
So sine of the first, cosine of the second, and
Plus cos A. Sine.
okay. Is that correct?
Yeah.
So what does a and b stand here?
Same.
So a stands for, so first one, right? So a is theta, agree? So this is like a, and this is b. Make sense? And then you apply the formula the same way. So that equals, and this time I'm asking Valerie, can you help?
You would just plug it into the.
Yeah, so how do I expand that? The right side, see? How,
So it'd be sine theta.
so sine of the theta, okay, let me write the theta. Then,
And then use cosine of theta. Or the blue one.
okay, let's put it, yeah, the blue one. So first one is sine of the theta, then times cosine of,
Theta.
yeah, theta, which is the blue one, right?
And then plus cosine of the red theta.
Yes, I want to hear that cosine of the red theta. So the color coding little helps, right? Otherwise it becomes confusing. So if you know which one is A is what matters right now. I'm taking the red one, right? So that's A, and that's A, correct?
And
So right now everything is theta. So cosine of that, and then
sine of the blue one.
sine of the blue angle, and that is theta. So far so good? Now what do you see when you look at it? If I ask you, watch this, x times y, and I say y times x, what is this? Both are same, right? This is x, y, this is y, so what? If it is y, I can always write it as back to xy, right? But are they not the same thing? So how many of them? This is one, this is another one, total is 2xy. Got it? Two of them, it's like two of those. So do you see the same thing here? So sine theta, cosine theta. This also is sine theta, cosine theta. This is not the same thing? So the only thing is this is written second, so you can rewrite. So let's write sine of theta, cosine of theta, plus this I will swap this using the commutative property and then sine theta and cosine. Is that okay? And then they are the same, right? So you just write twice. So two of this. So this and this is twice. So we say, okay, 2 times sine theta times cosine. Is that okay? So these are double angle formula, that is, and this is the right. So you just prove. So what I will do, is first we'll do only the second one we'll do later on because I don't want to get too much. First we'll do then this cosine formulas and then 10 to. Okay? Do you understand? Okay, so the next one is cosine. So this is sine 2 theta is done, right? So start with the left and let's see why cosine 2 theta is cosine square or minus, let's see why it is like this. Is that okay? So how do I start with first? Yeah, cos of? You should talk. You should talking?
Yes.
Okay. So what's cosine of 2 theta? At the most, what can you write this as? Cosine of theta plus. Is that okay? So can you think of which formula to be used here? You know, would you like to go on the board? Try? Do you want to try on the board yourself? Come. So by now you should be doing trying. Okay? So you're going to use the other formula, the cosine formula, okay? Black marker word black. Wow, beautiful. That's correct. And then what about that? If you multiply cosine and cosine, what do you get?
Cosine, cosine.
Yeah, two of them, right? So multiply itself means what does that mean?
Square.
Square. So where are you going to put? Cosine. Theta, correct. Okay, yeah, that also is correct. Perfect. And then minus. Can you make it a little bigger so that the camera can take it? No? It's not coming. See, he's doing. No? Okay, I forgot. Yesterday we did one problem, algebra to was so nice. That was a nice problem. He did so much. The student forgot, he did some mistake. He clicked twice. So he went on and off. And the whole thing was, oh my God. I said, what, Jacob?
Is that it?
But do we keep this way or there's another nice way to write instead of so many parentheses?
You do cos squared
Do you agree with her? Yeah. Instead of putting it up there, it becomes so much work. You just put little that 2 to this part, where the 2 is written down. It's almost the same thing what you wrote. Only thing the 2 is put just above that. Yeah. Just put above the S. Did you learn something? So the question is why it is X, okay? Thank you so much. The first part is beautiful, so we did so far, and that's the right side. So I'm done, the first part is done. So this is the A. Can you see that I wrote there? I think I wrote B 1, 2, 3. So this is B. So this is B. And the one that we proved right now here, this is B of 1. So that's the one we did. Can you see B1 here? So this group is A. This is set 1 for double angle formula. This is B. This is C. So I just call them A, B, C. A is for sine, B for cosine. So if it is B, there are three parts for B. One is this one. So is this 7 or something? No, there are 7 cosine, I think. Should I write cosine 7 times? No? Just kidding. Okay. Is that your 2, this one? 2, right? I'll make it beautiful. Is that okay? What's that? Now the question is, we did the first part, agree? Yes or no? Can we prove the second one? How do you get, there's no sign here. Can we change sine square by something else? So what do I change this to? In place of sine square, can we replace it with, in the form of cosine? If you see this formula, can you use this here? What do you see? I want to replace sine square.
Oh, it would be 1 minus cosine squared. Yeah.
This one, right?
Yeah.
So we want to replace sine square. So sine square is 1. Correct. See how everything is now, you kind of we have to use so much of trigonometry, and this is a real good challenge to understand this. So this is 1 minus cosine square of, now I'm putting a theta parenthesis just to, of course this is correct. You could skip the parenthesis also. Sometimes some students just write like that. That's okay, correct. As long as you understand what it is. But if you write this way, it looks organized. Let's open this. So this is -1, right? So this -1 time. So when you use the distributive property, cosine square theta -1 and 2 negatives makes it positive. Is that okay? Are you almost there, right? Okay, so what we do, so what can we combine this? They look alike, right? You see? That is cosine square, this also is cosine, 2 of them. So when you say 2 of them, this is in words, but we can say, hey, twice cosine. And this -1 stays -1. And that is nothing but B2. So the second formula, see? This part, B2. So it's like writing in terms of, like, we can always write the same thing with using, this could be one of the answers. Or it could be this also, see? This is the second one, agree? Now what I'm going to do next is, we will use this and make an arrow, and I want to use B3 here. So this is B1, and we proved B1 here. From here I proved B2, but we can use the same for B3. It means this, in place of replacing, instead of replacing sine square, can we replace cosine square here? Do you get what I'm saying? Here we replaced we had replaced, I'll just write. So this was replaced here. But now I want to replace the other one. Here, you replace cosine square. So what do I write instead of cosine square? What is cosine square from there? 1 minus sine square, right? So we can replace this cosine square is 1 minus sine square. And this is the blue one is already there, right? So that one I have a minus sine. Is that okay? So this is what is 1 minus? So 1 minus, how many of them? 2 negative, right? It's like if you have negative x and negative x, how do we write this? Is that okay? So same thing, they look alike, they both are negative, so minus twice sine square of theta. So that's B3, correct? So cosine 2 theta, there are 3 formulas. One is if you want both cosine square and sine square, or you want only cosine square, or you want only sine square. So that's how I do it. And the last one, let's say tan 2 theta. Can you try yourself this one? Without my help. Okay, I'll keep quiet for a while, and 1 minute you can talk and see. Yeah, this one you can try yourself.
Oh.
Like yesterday's formula, the chart is over there. Oh, yeah, where's the chart? There it is, right? See the formula for tan. Tan A plus B, use that. So Jaslyn has to come on the board and do, or last time Hugo came. Easy, right? Getting a hang of this formula, so many, right? Remember, these are mostly used, of course, we are going to use less, but when you go to the calculus class next year, that's where every time you're going to use this. Do you remember using this, Jaslyn, in calculus class? No? Integration. Look, watch. Jaslyn, if they ask question, integral of, what is integral of sine square of x? Dx. You don't remember this? You remember integral sign, right?
No, I remember I did it, but I remember.
You don't remember Valerie? Integral. Anti-derivative.
I remember we did them, but I
Yeah,
don't
so,
remember what we did.
okay, let's see the derivative of cosecant x. E is minus cosecant x cotangent. Do you remember this? No? Something? Yeah, now it's 2. Okay, so to tell you the truth, once you get used to this trigonometry, all that stupid thing, this integral becomes easy. Now, let's see tan, we want to prove tan 2 theta, and that is C, right? So C, let's write C. So the double angle formula, what is tan 2 theta? And Valerie, I want you to come do this. I know, if you get caught on there, but that's fine. So same thing, instead of 2 theta, what do you got?
You'd put, and then you would split it into sine and cos?
No, don't have to. You can use the one that we already did yesterday. Or the other chart. Let's write the formula here. What is tan of A plus B? Yesterday we did this. So
Tan A
tan,
plus tan B.
yeah, tan A plus B is, markers are getting over, nobody pays me. Anyway, tan of A, correct? Tan of plus tan of. Remember we did this over the end, almost ending, and then 1 minus tan of the A, the first one, times tan of the second one, correct? So use that.
So then it would be and then you can put these two together, so it'll be two.
Then,
tan.
you also have to decide, right? So two of them, so tan twice tan.
And then these would also come together, so it comes squared. So 1 minus.
That's it. So simple, right? Good job. But what about one more thing is, so students usually they ask, so let's write 10 or what is this? 2 theta, right? That's what we started and we got 2 tan theta, 1 minus, yeah. So what I wanted to show is, everybody got it? Okay? Now the next part is, let's see why this is the tough one, this is the hard, let's do this one, okay? The one that I skipped, this, we'll see the next one, why those formulas. Okay, we'll do that.